Okay, so 8.1 is going to cover 3 different variations that we'll look at. Direct variation is an algebra 1 skill, and then we'll do joint variation and inverse variation. Then we will move to 8.2, which is graphing your rational function. Okay, so with direct variation, that formula is y equals kx, where k is your constant of variation. Okay, so in algebra 1, I think we used a. But it doesn't matter if it's A or K, either way, it's a constant of variation. Okay, so your Y and your X are your variables, your K will be a number. Okay, so what you're trying to do is find what that value is given two values, your X and your Y. And then once you get that equation, you're going to find a specific Y for a specific X. So if it says Y varies directly as X and Y equals 9 when X equals 15, we have to know the moment you read directly, it's going to be that Y equals KX. So in the notes, it's easy to know because it's separated, but on your worksheet and your test, you have to know the formula based on that one keyword, okay? So if Y equals 9 and X equals 15, all I'm going to do is plug that in. So 9 equals K times 15. So if K is being multiplied by 15, what do I need to do to solve for K? Divide by 15. So 9 divided by 15 simplifies to what?
3/5.
3/5, good. So we're going to use that K value, and we're going to come up with our equation, Y equals 3/5 X. That's our general equation for that relationship. And then we're going to find Y when X equals 21. So then you're just plugging in 21 for X. So Y equals 3/5 times 21. 3/5 times 21. 21 should give you, hopefully, 63/5. Very simple. Okay. So joint variation is when you're going to have Y equals K times X times Z. There's a third variable. Okay. So it says if Y varies jointly as X and Z, when Y equals 96, Z equals 4, and X equals 8, we need to find that constant variation before we find the next Y value. Okay, so we've got 96 equals K times our X of 8 times our Z of 4. So 8 times 4 is what?
32.
So 96 equals 32K. Divide by 32, and K equals what?
3.
Should be 3. So then Y equals 3 times X times Z. That's my equation. And so what is our Y value when X equals 7 and Z equals 12? So we have Y equals 3 times 7 times 12. What's that going to give you?
252.
We're good with that? Now, inverse variation is Y equals K divided by X. So Y and X are inverse. So this example shows that it's not always going to be Y and X. So this one says if R varies inversely as T. So whatever variable comes first is that Y position. So R is going to be in place of Y, and the T will be in place of X. So we're really solving for R equals K over T. So it says R equals 18 when T equals -3. So I have 18 equals K divided by -3. So how would I solve for K? Multiply by -3. So K equals
-54.
So R equals -54 divided by T. So then we find R when t equals negative 6. So R equals negative 54 divided by negative 6. And that gives you
9.
Okay, just look at that. So it says, for our next example, y varies inversely with x, and x equals negative 4 when y equals 3 halves. Find the constant variation, then write an equation relating x and y. Finally, find y when x equals 5. That is just what we've been doing, just has more words typed in. Okay? So, exact same thing, you just have to recognize that keyword of inversely. Okay, so what is my formula if it varies inversely? Good, y equals k over x. So if x equals negative 4 when y equals 3 halves, we're going to plug those two values in. 3 halves equals k divided by negative 4. Multiply by negative 4. And k equals what?
Over 6.
So y equals negative 6 divided by x. That's my equation. So what will y be when x equals 5?
Negative 6 over 5.
Mm-hmm. You're good with that? So now we put it together with a word problem. The volume V of a gas varies inversely as the pressure P under which it is contained. If the volume of a gas is 240 cubic centimeters under a pressure of 20 kilograms per square centimeter, what is the volume when the gas is placed under a pressure of 24 kilograms per square centimeter? So what's my relationship? How does it vary?
Inversely.
Inversely. So what's my formula? Instead of y, we've got V equals P. V equals K over P. So what's my next step? What am I going to write?
240 equals k over 20.
Good. And how do I solve for K?
Multiply by 20.
And so that's going to give me a K value of what? 4,800. Good. So our volume is equal to 4,800 divided by the pressure. So whenever you plug that pressure in, 4,800 divided by 24 gives you what volume? 200. What's my units?
Cubic centimeter.
Mm-hmm. So if you have a word problem and it has units, make sure that you use those units in the answer. Okay, y'all good with that? We have questions? So now we're going to go back to rational functions. Okay, we have simplified, multiplied, divide, added, subtracted, and now solved rational equations. Now we're going to look at a graph. Okay, so remember with rational expressions or functions or equations, you cannot divide by 0. Okay, so when we had restrictions in 8.5, when we were solving the equations, we're going to have the same restrictions for our graphs. Okay. Now, usually when we graph, we do transformations. We're not looking at transformations here. We're just gonna do the pieces that we need for the graph, and get the table from the graphing calculator, and then find the domain range. Okay? It's not hard, but there's a lot of steps to do. So you can't forget the pieces. All right? So I did put the parent function here just for you to know it. F of x equals 1 over x in case you need it in the future. You will do rational functions and equations and all of that in pre-cal, so it doesn't hurt to see that parent function, okay? When you are doing rational functions, our first step in everything we've done so far is factor, and that's still gonna be your first step, okay? Factor if you can. Then you're gonna find the restriction, so remember that's when your denominator cannot equal 0 because you cannot divide by 0. Okay, so you wanna find that first. Then you're gonna find your x-intercepts, and that is when your numerator is equal to 0, because your x-intercept is the point where it crosses the x-axis when y is 0. So you just really need to set your numerator equal to 0 and solve for your x. If something happens and the x disappears for some reason, and you get a number, 0 is equal to another number, that's not true, so it would be no x-intercepts, okay? Then once you find your x-intercepts, you're going to find your y-intercepts. That's the point where it crosses the y-axis when x is 0. So then you just plug in 0 for all of your x's and get the value for your y-intercept. Okay. Now the vertical asymptote comes directly from your restrictions. So remember with logs we had asymptotes with that and exponential functions. So with rational functions, you have both vertical and horizontal asymptotes. So your vertical asymptote comes directly from the restriction on the domain, what the value cannot equal in the denominator. Okay. Your graphs will never cross a vertical asymptote because it is a restriction on the domain. For our horizontal asymptotes, you've got 3 rules that you're going to have to know. Okay. And they all refer to the degree of the numerator and the degree of your denominator. When I say the degree, do you know what I'm talking about? Do you remember from chapter 5? The degree of a polynomial came from where?
Wasn't it the opposite of the?
No.
was
So
one of
degree, think about when you do a degree symbol, where is that? What position is that? An exponent. So the degree of the numerator is the exponent, and your highest exponent in standard form. Okay, so degrees of polynomials are your highest exponent in standard form. So you're going to analyze the numerator and denominator. So if the degree of the numerator is less than the denominator, then your horizontal asymptote is at y equals 0. So what is an example of that? If I have something like, let's say y equals x minus 2 over x squared minus 3x plus 2. Okay, the degree of my numerator in this situation is 1. The degree of my denominator is 2. 1 is less than 2, so my horizontal asymptote would be y equals 0. Okay. Now, if they're equal, if the exponents and the degrees of the numerator and denominator are equal, so something like y equals 3x squared minus 1 over 2x squared plus x minus 1. Okay, the degree of the numerator is 2, the degree of the denominator is 2, so what you do is you take a ratio of the leading coefficients. So that just means you divide 3 and 2, so that becomes y equals 3/2 for your horizontal asymptote. So that could change. It's not one set thing like the y equals 0. It depends on your problem. Okay. Then, if the degree of the numerator is greater than the degree of the denominator, then you have no horizontal asymptote. So if I have y equals something as simple as x plus 2 over 4, that would have no horizontal asymptote because the degree of the numerator is 1, the degree of the denominator is 0, because you don't have a intercept. Okay, so you have to know those 3 rules. Okay. Now, your graph cannot cross a vertical asymptote because it's a restriction on the domain, but there is a possibility that it can cross the horizontal asymptote because it just comes from the exponent. There's no actual restriction anywhere. So you're going to see, does it cross that horizontal asymptote? And the way you're going to do that is you're going to take your original problem and you're going to set it equal to the value of your horizontal asymptote. If you get an x value, then that's the x value that it crosses at. if you get your x's canceling and say 0 equals 4, then it does not cross. Okay. So you're going to have to check for that. It does not specifically say that in your instructions, so you're going to remember to check. Okay. If you do all of that, then you type it in your calculator, you get a table from the calculator, you graph it, and then our last step is domain and range. Okay? So not hard steps, just a lot of steps to remember. Okay? But your instructions tell you everything you need to find. Okay, so find the restrictions on the domain, x and y intercepts, equations of the asymptotes, points of discontinuity if they exist. I didn't talk about that yet because I will when it happens. Okay. Then graph each function using C-chart, state the domain and range. So everything is there. Okay, the only thing that's not there is specifying find the equation with the horizontal and vertical, and it telling you to check if it crosses the horizontal. Okay. So our first example that we're going to have is f of x equals 3x minus 1 over x minus 3. So I checked, can I factor it? I cannot. So then I need to find my restriction on my domain. So I said that x minus 3 in the denominator not equal to 0. So x cannot equal 3. Once I find my restriction, I need to find my x-intercept. I do that by setting my numerator 3x minus 1 equal to 0. Add your 1 and divide by 3, and x equals 1/3. Remember, your x and y intercepts are points on a graph, so we're going to write it as an ordered pair. It will be 1/3, then 0. Now, I'm getting a fraction algebraically. If you want to give me the decimal, that's fine too. You're graphing, so I'm good with either. Okay. I typically do the fractions within the work and then find the decimal on here. Okay, so then our y-intercept we find by taking 0 and plugging it in for the x's. So f of 0 would be 3 times 0 minus 1 over 0 minus 3. All you're essentially doing is getting rid of those x's with zeros, and you're looking at your constants in your equation, in your function. That's going to give me what? Should be a positive 1/3. Because you have negative 1 divided by negative 3. And so as an ordered pair, it's going to be 0 1/3. Then our vertical asymptote comes directly from our restriction. If x cannot equal 3 for my restriction, that means my vertical asymptote is x equals 3. It's the same exact thing. Now our horizontal asymptote comes from our rules. So what is the degree of our numerator? 1. What's the degree of your denominator? They're equal, so I take the ratio of the leading coefficient. So my horizontal asymptote would be y equals what? 3. Because you are doing 3 over 1, which is 3. Okay, then you're going to check, does it cross? So what I'm going to do is set my original 3x minus 1 over x minus 3 equal to that value I just got for the horizontal asymptote. So I'm going to set it equal to 3. And I want to solve. So if I want to solve this, I need to multiply both sides by that denominator to get rid of that fraction. That will cancel the denominator, leaving me with 3x minus 1 equals 3x minus 9. When I go to solve this, I need to subtract my 3x to get it to the left. Negative 1 equals negative 9, which is not true. It does not cross. You can tell me no. You can tell me does it cross. You just have to notate that one way or the other. It crosses or it doesn't. Okay. So then what I do before I get my calculator is I go ahead and plot what I know. I know I've got two asymptotes, so I make those dashed lines at x equals 3. And y equals 3. And I'm going to go ahead and plot my x and y intercept. And then when you're done with that, go to your calculator. If it's not been cleared already, go ahead and doc B it. We're going to go to the graph in the scratch pad and we're going to type our original function. Control divide will get you your fraction. I'll have 3x minus 1 over x minus 3. Control T will get your table. Now, when we're getting our values for our table, our x-axis goes from negative 11 to positive 11. So I'm going to go up and start at that negative 11. Okay? That doesn't mean I'm going to copy down every single point from negative 11 to 11. I'm not doing that. Okay? If you notice, all of these decimals look really similar. This rounds to 2.4, 2.4, 2.3, 2.3, 2.2. On a graph, that's all going to look the exact same. Okay? So I'm not going to tell you specific points that you need to have, but you should have enough to make the full correction. Okay? So what I mean by that, all of these are pretty much the same. Okay, so I'm going to look, and I could probably stick with just negative 5, 2, because negative 5, 2, and this negative 11, 2.4 is going to look pretty much the same. Okay, so I'm going to start at that negative 5, 2. And then I'll probably skip to that negative 2, 1.4. You can skip around as long as you have enough to make all the curves. Okay. And so I'll have that negative 1, 1. That 0 and 0.3 is already on my graph from the x-intercept, the y-intercept. And then 1, negative 1. 2, negative 5. 3 is undefined because that is your restriction, and that's your asymptote. And if I keep going, I've got my 4, 11, 5, 7. I'll probably skip the 6 and do 7, 5. And I can probably skip to 11, 4. Okay? So I'm not going to count off if you don't have every single point from negative 11 to 11. But if you only give me like 3 points, then obviously that's going to be a little long. Okay? So have enough to make your 2 curves. Sometimes you're going to have 2 sections of your graph. Sometimes you're going to have 3. Okay? Okay, once we graph it, we need to talk about the domain and range. I really don't have much room, so I'm gonna write it and it's gonna run over my graph, but it'll be fine. So our domain goes from left to right because it's a set of all possible x values. What is the only restriction for domain? What'd you find in step 1? Can't be 3. So for our domain, we're going to go from negative infinity to 3, but we cannot equal it. So if it doesn't equal, what do we put in our interval? Parentheses or bracket? Parentheses. The bracket means it's equal to. All right, so I've got negative infinity to 3, and then I put my U for union, and I pick it back up at 3, but I go to infinity. Even though it ends and starts at a 3, because you have the parentheses, that's telling you it does not equal 3. That's how you tell it to me. Okay. Now, if we were doing set builder, you could tell me all numbers except x cannot equal 3. But we're doing interval right now. Okay, so that's what it should look like. All right. So for my range, if you look at that graph, what is the only restriction on my range? Y cannot equal 3. Again, just happens to be coincidence. Okay, so our range, you're going to go from bottom to top, so negative infinity till you hit that 3. Pick it back up at 3 and go to infinity. There we go with that example. All right, our next example, we have f of x equals x squared minus 2x minus 8 over x squared minus 9. Okay, I checked, can I factor that? That numerator, factors of negative 8 to give me a negative 2 would give me what? X minus 4, x plus 2. And then that denominator, x squared minus 9. Good. Difference of 2 squares. X plus 3, x minus 3. Then I check, can anything simplify? I can't cancel anything out, but it's good to see it in factored form for when you do your x-intercept and your restrictions. Okay? So my first step is my restrictions. I do not have to see you set x plus 3 cannot equal 0, x minus 3 cannot equal 0. Y'all are pre-AP. You should be able to tell me your 2 restrictions, right? What are they? X cannot equal negative 3 and x cannot equal positive 3. Okay, so then for my x-intercept, I set my numerator, x minus 4 times x plus 2 equal to 0. So that gives me what 2 x values? 4 and negative 2, good. So remember you write that as an ordered pair. So that's going to give me 4, 0 and negative 2, 0. So then our y-intercept, we're going to plug a 0 in everywhere we do an x. Now, I personally do that in my original because it's easier to see what that's going to come out to. Okay, so f of 0 tells me I have 0 squared minus 2 times 0 minus 8 over 0 squared minus 9. Again, you should just understand that you're basically getting rid of those x's with 0, and you're left with your constants, which is going to leave me with 8 over 9. So as an ordered pair, that's going to be 0, 8 ninths. Then for our vertical asymptote, what is that going to be? It's directly from your restriction. So x equals -3 and x equals 3. Now my horizontal asymptote, what's the degree of my numerator? 2. What's the degree of my denominator? They're equal. So I take the ratio of my leading coefficients. What are my coefficients?
1,
So y equals
1.
Now we need to see, does it cross? So we're going to set that x squared minus 2x minus 8 over x squared minus 9 and set it equal to 1. When I do that, I just need to multiply by that denominator, x squared minus 9. That gives me x squared minus 2x minus 8 equals x squared minus 9. When I go and solve this, I subtract my x squared, but that will cancel out, leaving me with -2x minus 8 equals -9. Well, I still have an x, so I'm going to add my 8 to that -9, so -2x equals -1. Divide by -2, x equals 1/2. So what that means is it crosses the horizontal asymptote at 1/2, 1. So I take the x value that I just solved for and the horizontal asymptote y value and put that together as an ordered pair because that is where it's crossing it. Okay? You understand that? You have questions? So now I'm going to graph my vertical and horizontal asymptotes. That 4, 0 and -2, 0 will be in my table, but I'm going to go ahead and plot them along with the 0 and 8/9. And that 1/2, 1, I'm going to put a dot because I know it crosses right there. Once I do all of that, I'm going to go to my calculator, doc B, back to the graph, control divide, we'll get my fraction, and I'm going to type my x squared minus 2x minus 8 over the x squared minus 9. I see 3 sections, and I noticed that I should have 3 sections on my graph in my paper. So control T. And I'm going to start at -11. All of those points are around 1.2 or 1.3. So if I wanted to, I could start at -6 and 1.5. That's what it would round to. And then I can have that -4, 2.3. At -3, it's undefined. And I've got the -2, 0, -1, 0.6. That 0, 0.9 is what we already figured out for our y-intercept. And then you can do that, let's say 2, 1.6. 3 becomes undefined again. 4, 0. If you want to do one of those 0.4s or 0.6s, you can. If you keep going, it all rounds to 0.8. So if you just want to skip to 10, 0.8, that's fine too. Just make sure your graph looks like the graph on your calculator. Okay, for my domain, I've got 2 asymptotes. That breaks my graph into 3 sections, so I'm going to have 3 domains. So, or 3 domain intervals. I'm going to go from -infinity to where?
-3.
-3. And my next interval will be
-3.
good. And then to infinity. Now, what about my range? What do you think the range is going to be? Do I have a restriction on my range?
No.
Why not?
It looks like you got
In which section?
the middle.
The middle. So if the middle didn't look like that, then we would have a restriction on y equals 1. But because it crosses that horizontal asymptote, I can put -infinity to +infinity for my range. You understand that? Alright. We have just 2 more to do. And I don't want to skip one because the first one is more simple than the second one. When you do the degree of your numerator, so for here, the degree of the numerator is x squared, so that's 2. The degree of your denominator is 2. Since they're equal, you take the coefficients and divide them 1 divided by 1 because we have 1. Other questions? Okay, so now we're going to talk about a point of discontinuity, which is a removable discontinuity. Your graphs are continuous for each section, and that's why I hound y'all about arrows, because your graphs are continuous functions, okay? If you don't have arrows, then it makes it discrete instead of continuous. So what's happening with a point of discontinuity is you are able to cancel out a factor once you simplify it, okay? And so what would usually cause a vertical asymptote now causes a hole in the graph instead of an asymptote, okay? So we're gonna, if we have that situation, you just put an open circle for that one point, okay? So if I have this example of x squared minus 25 over x minus 5. When I factor this gives me x plus 5, x minus 5 over x minus 5. And what can I do from there?
Cancel out, it's fine.
I can cancel out x minus 5, and that just leaves me with x plus 5. What do you know about x plus 5? What type of function is that?
The normal.
The normal linear. Okay. So I went from rational to linear. So when I typically would see a restriction at x cannot equal 5, that is not a restriction anymore. That creates a hole in my graph because I canceled it out. That is my point of discontinuity. So we have to figure out, okay, we know the x value, but we have to know the point of discontinuity as an ordered pair. So we need to solve for our y. So you're going to take that 5 and you're going to plug it in to your simplified version, 5 plus 5. That gives me 10. So there is a hole in my graph at 5, 10. It is no longer an asymptote. So when I write that there's a hole in my graph, I automatically go to that point and I do an open circle because I don't want to forget that. And then we move on with everything as normal. So our x-intercept, we set our numerator, which is just x plus 5 equal to 0. That gives me x equals negative 5. So negative 5, 0 as an ordered pair. Which if you want to go ahead and put on your graph, you can. Then our y-intercept, what do you know about the y-intercept of a linear equation or a linear function? Linear is what form? Y equals what?
MX plus B.
Mx plus b. What do I know about that?
The y-intercept is B.
Your y-intercept is b, so what's my y-intercept?
5.
Okay, so it should be 0, 5. What do I know about my slope?
1 over 1.
It's just 1. So I'm not going to ever put linear in my graphing calculator because you should be able to graph that. But if you plot your points, you have enough to make a line. Okay. So then after the y-intercept, we don't have a vertical asymptote anymore. It's now our point of discontinuity. Okay. So then if we think about a horizontal asymptote, we go back to the degree of our numerator and degree of your denominator. Well, if I look at my simplified version, the degree of my numerator is what?
1.
1, because it's just x. The degree of my denominator is 0, because there's no variable. It's a constant. 1 is greater than 0, numerator is greater than the denominator. That tells me there is no horizontal asymptote. Okay. So, I don't have to check if it crosses because I don't have a horizontal asymptote. I can now just graph and do domain and range. Okay. Now you all should have your ID around your neck, so you can use your ID as your ruler for this. If you've already plotted your x and y intercept, then you have enough points to draw that line. Or you could do your slope and get each up 1/1 point. So with linear, typically domain and range is all real numbers, but we can't put that because we have a hole in our graph. So what is our domain going to be? You always start at negative infinity. And where do you go? All the way till you hit your point of discontinuity, which is at 5. And you pick it back up at 5 and go to positive infinity. So my range, what's my range going to be? Negative infinity to where? To 10, where I've got the hole. And then 10 to infinity. Okay, we're good with that. One last one. Okay, so we've got f of x equals x squared minus 3x over x squared minus 2x minus 3. So I can factor the numerator. What can I do with that? Put down the x as GCF, so x times x minus 3 leaves me with, what is my denominator? X minus 3 and x plus 1. So what happens?
X minus 3 and x minus 3 cancel.
Leaving me with x over x plus 1. So because I now still have something in my denominator, I can come up with a restriction that x cannot equal -1. What do I do with that x minus 3 that I originally had? What does that cause?
A hole.
A hole. So x cannot equal 3. We're going to find where that hole in the graph is. Okay, so we're going to find f of 3. So we plug that into our simplified form, 3 over 3 plus 1. And that's 3/4. So our hole in the graph is where? 3/4. So that is your point of discontinuity. So I'm going to go ahead and make an open circle there. So then when I move on to my x-intercept, equal. So I take my coefficients, 1/1, which is 1. So then we need to check, does it cross? So I take x over x plus 1 and set it equal to that value of 1. Multiply by x plus 1. X equals x plus 1. I would go to subtract my x. Leaves me with 0 equals 1, which is not true, so it does not cross. So I'm going to plot my x equals -1. And my y equals 1. And my 0, 0. Now, when you have a problem with a point of discontinuity, when you type it in your calculator to graph, if you type in your original, it will have an undefined for this whole. If you type in your simplified version, it will give you that 3 and 0.75 because technically there's nothing wrong with the simplified version. Okay? It does not matter which one you choose as long as you remember in your table there is no 3.75. That's a whole. Okay? So it doesn't matter. You're going to get the same graph either way. Okay? So if you want to go ahead and just do the original, you can type control divide x squared minus 3x over x squared minus 2x minus 3. Control T. So all of these decimals are really close to each other. Okay. If you see they start getting larger at -3, 1.5, I could probably just use that. Then I get -2, 2. And at -1, we know it's undefined. Then I've got my 0, 0, 1, 0.5. That 3, we know, has a hole, so it's undefined. Then we just keep getting to 0.8 to 0.9. So if you want to just go all the way to 10, 0.9, that's fine. What do I know about my down method? I start at negative infinity and I go where? To -1. And then I start back at -1. And where's my next stop? At,
The whole,
so at 3. And then I go from 3 to infinity. So then for my range, I go from negative infinity until when? That 0.75 with my whole or 3/4. It doesn't matter which one. And then from 3/4 until 1. And then 1 to infinity. You're all good with that?
fine.